All right, so this is going to be our walkthrough for the multiple choice derivatives homework assignment. And these are all old AP multiple choice questions or AP style multiple choice questions. And we're starting off with one that says, which of the following could be true if our second derivative is x to the negative 2/3? So the first thing I would do is just take the derivative, because I see I have an option here, option 3 is the third derivative. So if I take the derivative of f double prime of x, then f triple prime of x ought to be negative 2/3 x to the negative 5/3, which is exactly what this says. So we know that 3 is true, which means we can immediately eliminate options A and B. Then we'll go in and the next one I would do probably is just take the derivative of number 2, because its derivative should be x to the negative 2/3 if we are going to make that true. So the derivative of 10 is 0, and then 3 times 1/3 is 1. So 1x to the, and then 1/3 minus 1 using the power rule is negative 2/3. So it looks like option 2 is true, so we can eliminate option D. Now it's just down to number 1 here. So if we take the first derivative there, we're going to get 3 times 4/3, which would be 12/3 or 4. So 4x to the 1/3. And we can immediately see that's, when we take its derivative, not going to give us x to the negative 2/3 because, well, 3x to the 1/3 did. But we can see that this is 4/3 x to the negative 2/3, which tells us that number 1 is not true. So we can eliminate choice E, and our final answer should be choice C. For our second one here, we're just going to use the product rule on x sine of x. So our first function is x, so that'll be our u. And then our dv is the derivative of sine x, which is cosine x. And then we'll add to that the derivative of x, the derivative of the first function, which is just 1, times the sine of x. And so we can see our answer is x cosine x plus the sine of x. And if we look in here, it looks like that's option B. For our next one here, number 3, we're looking at a function that is being raised to the 5th power, right? We have u to the 5th, where u is equal to x cubed minus the cosine of x. So we should get 5u to the 4th times the derivative of x cubed, which is 3x squared, times the derivative of negative cosine, which should be positive sine. And since u was x cubed minus cosine x, it should be 5 times x cubed minus cosine x to the 4th power times 3x squared plus sine x, right? We just substitute our u in into our derivative. And so it looks like, what do we got here? That looks like that is option E. For number 4 here, we have a function that's defined by the square root of the absolute value of x plus 2. And we want to know which statement is true. Well, the easiest way to know which statement is true is to just understand that this is just like the square root of x plus 2 when the values of x plus 2 are positive. But then that absolute value just gives us a reflection here across the line x equals negative 2. So we can see that the function is continuous there because, we could go through a full limit definition of continuity, but we can see that the left hand and the right hand limits are both approaching 0. But it's not differentiable because what we've got here is a cusp. So our function is continuous, but not differentiable at x equals negative 2. And all the rest of these are true, right? All the rest of these, are not true. That it's not differentiable at negative 2. It is continuous at negative 2. Right? The limit as we approach negative 2 is 0, right? We're coming into 0 there. And there's no vertical asymptote there because if we tried to do the limits on the left and the right of negative 2, we would not get infinity. And if we weren't sure about what the graph looked like, remember that the absolute value of x is the same thing as the square root of x squared. So the absolute value of x plus 2 is the same thing as the square root of x plus 2 squared. So what we'd be looking at here is the square root of the square root of x plus 2 squared, or the square root of u, where u is the square root of x plus 2 squared. Now, that's a chain rule derivative. We do 1 over 2 root u times du dx. I'm not even going to bother to find du dx, right? If I put in u here, I have 1 over 2 root u, which is root x plus 2 squared. Well, we can immediately see that in our derivative, which still would have a du dx here, we would see that that derivative is going to be undefined when x is equal to -2. And so that also tells us that this function is not differentiable at -2. So for number 5 here, we're just looking at the derivative of cosine cubed of 4x, which is like, u cubed, where u is the cosine of 4x. So we want the derivative of u cubed, which will be 3u squared, so cosine squared of 4x. And then we need to multiply that by the derivative of cosine 4x. Well, that's cosine v, where v is equal to 4x. So that should be negative sine of v, or negative sine 4x, times the derivative of 4x, which is 4. So we should end up with negative 12 cosine squared 4x sine 4x, right, when we multiply the 4 and the 3 and the -1 all together. So negative 12 cosine squared 4x sine 4x is option B. For our next one here, we're looking for the derivative of x squared y minus 3x equals y cubed minus y at the point -1, 2. So we have to take the derivative of this implicitly, and we'll use the product rule on the x squared y. So that's x squared times the derivative of y with respect to x, plus the derivative of x squared, which is 2x, times y, and then minus the derivative of 3x, which is -3, is equal to 3y squared dy dx. Then we'll solve for dy dx. So we'll leave the 2xy minus 3 on the left-hand side, but bring the x squared dy dx to the right-hand side by subtracting it. We'll factor out the dy dx from the right-hand side. And then we'll divide to get dy dx is equal to 2xy minus 3 divided by 3y squared minus x squared. Well, we want to evaluate that when x is -1 and y is 2. So when x is -1 and y is 2, we have 2 times -1 times 2 minus 3 divided by 3 times 2 squared minus -1 squared. Well, 2 times -1 times 2 is -4, and -4 minus 3 is -7. And in the denominator, we've got 2 squared, which is 4, times 3, which is 12, minus -1 squared. -1 squared is 1, so we've got 12 minus 1, which is 11, giving us -7 over 11, which is answer choice A. For number 7, we just want to find f prime of 2, so we want the derivative of f of x. We'll use the power rule for that. F prime of x is 3x squared minus 2x plus 1. And then we'll just evaluate it at 2. So 3 times 2 squared minus 2 times 2 plus 1. Right, so that would be 12 minus 4, which is 8, plus 1, which should be choice B, 9. And again, here we just want the instantaneous rate of change of f at x equals 3, which means we want the derivative of this function at x equals 3. So we'll take our derivative using the power rule, right? F prime of x should be 3x squared minus 12x plus 8. And then from there, we'll just evaluate it at 3, right? Because instantaneous rate of change is just the slope of the tangent line. So this is 3 times 3 squared minus 12 times 3 plus 8. Right? Well, 3 times 3 squared is 27 minus 36 plus 8, which should come out to be -1, which is answer choice C. For number 9 here, we just want to find the derivative of the function 5x times root x squared plus 1 at x equals 3. So we'll take our derivative using the product rule, since it's a product of two functions. So y prime will be 5x times the derivative of root x squared plus 1. So that's root u, so 1 over 2 root u. And then times the derivative of the x squared plus 1, which is 2x. And we'll add to that the derivative of 5x, which is 5, and then just times the square root of x squared plus 1. We want to evaluate this when x is 3. We don't really need to simplify, other than we might as well get rid of these 2's. So we have 5 times 3 over the square root of 3 squared plus 1, which would be the square root of 10, and then plus 5 times, again, the square root of 10. Well, 5 times 3 is 45, so we have 45 over root 10 plus 5 root 10, which looks like choice D. For number 10, we are given two functions f and g that we don't actually know the explicit form of the functions, but we do know their values at x equals 3 and their derivatives values at x equals 3. And we're asked to find the derivative of k of x, which is the quotient of f over g, evaluated at 3. So we're just going to use the quotient rule here. If we want the derivative of k at 3, that should just be the quotient rule. Like I said, g of 3 times the derivative of the numerator, the derivative of f at 3. So that's v, the denominator, and du, the numerator. And then minus our numerator function, right? So f of 3, and then times the derivative of g at 3, all over the original denominator at 3 squared. And so we'll just plug in the values there. So g of 3 is 2. F prime of 3 is 5. F of 3 is -1. G prime of -3 is -2. And then again, g of 3 is just 2, so it's all over 2 squared. So we've got 10 minus, looks like 10 minus 2 over 4. Well, 8 over 4 is 2, which is answer choice C. For number 11, we've got two functions, f of x and g of x, and we want the derivative of the composition of them. So one option is to do just the chain rule, f prime of g of x times g prime of x. And so we can just evaluate the derivative of f at g of x, and then multiply that by the derivative of g. But I think in this case, it's easier to just actually do the composition. F of g is just the square root of 3x minus 2 squared minus 4. Well, 3x minus 2 squared is 9x squared minus 12x plus 4. And then we still have that minus 4. That plus 4 and that minus 4 should just cancel out. So really, we're just looking at the square root of 9x squared minus 12x, and we want its derivative. Well, the derivative of that should be 1 over 2 root 9x squared minus 12x times the derivative of 9x squared minus 12x, which is 18x minus 12. Then we just want to evaluate this when x is equal to 3. And so at x equals 3, if we want to, we can, might as well do this. We can cancel out this 2, right? Because this is 2 times 9x minus 6. So we can cancel out the 2's. So really, we've got 9x minus 6 in the numerator. Well, 9 times 3 is 27. So we have 27 minus 6 over the square root of 9 times 3 squared. And 3 squared is 9. So 9 times 9 is 81. And then minus 12 times 3, so minus 36. So we've got 21 over root 45. Well, root 45, we should be able to break that down. So this is now 21 over
root 45 is root 9 times root 5, so 3 root 5. 21 over 3 is 7, so we have 7 over root 5, which is answer choice A. For number 12 here, we've got the function x over x plus 2, and we want to know when is the line tangent to f going to have a slope of 1/2. So we just need to find the slope of the tangent line of f and set it equal to 1/2. So the slope of the tangent line would be the derivative, right? So f prime of x will be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. Oops, not the denominator, the derivative of the denominator. So x times 1 all over the denominator squared. And so if we simplify that down, we end up with just, well, the x minus the x cancels, so we have 2 over x plus 2 squared. And we want to know for what values of x and y does that equal 1/2. Well, we just cross multiply to get 4 equals x plus 2 squared. Square root both sides to get x plus 2 is equal to plus or minus 2, or x is negative 2 plus or minus 2. So x is equal to 0, or x is equal to negative 4. We do want to make sure that our function is actually defined at those points. Right? So f of 0 is equal to 0 over 2, so that's 0. And f of negative 4 is equal to negative 4 over negative 4 plus 2. Well, negative 4 plus 2 is negative 2, so we have negative 4 over negative 2, which is 2. So it looks like the points at x equals 0 and x equals negative 4 will defined. We get the point 0, 0 and the point negative 4, 2, which is answer choice C. For number 13 here, we just want the derivative of this at 2. So the derivative of 8x to the negative 2 should be negative 16x to the negative 3. And then the derivative of 1/2 x to the 4th, also using the power rule, should be 2x cubed. We're just going to evaluate this at 2, so that'll be negative 16 over 2 cubed, right? Because x to the negative 3 means drop that power to the denominator. And then plus 2 times 2 cubed. So we have negative 16 over 8, that'd be negative 2. And then plus 2 times 8, 2 times 8 is 16. So negative 2 plus 16 is answer choice B, 14. For number 14 here, we want the derivative of the cosine to the 4th of x cubed. Well, that's like u to the 4th, where u is equal to the cosine of x cubed, because u to the 4th, like the 4th power, is the outermost function going on here. So we should get 4u cubed. And then we need the derivative of cosine of x cubed. Well, that's u is equal to cosine v, where v is x cubed. So the derivative of cosine v is negative sine v, and the derivative of v is 3x squared. So the negative and the 3 and the 4 will give you a negative 12 out in front. Then we have u cubed, so that'd be cosine cubed of x cubed. And then we have the sine of v, so that'd be the sine of x cubed. So we want negative 12, oh, we forgot our x squared. Negative 12, and we have that x squared also. Negative 12 x squared cosine cubed x cubed times the sine of x cubed, which is answer choice D. For number 15, we're just looking for the derivative of 2x minus 1 over x squared plus 1. So we'll use the quotient rule. So that'll be our denominator times the derivative of our numerator, which the derivative of 2x minus 1 is just 2, minus the numerator times the derivative of our denominator, which is just 2x, all over that denominator squared. And if we simplify down here, we got a 2x squared plus a 2. And then we're going to have a minus a 4x squared. And we're going to have a minus 2x, so a plus 2x, all over our x squared plus 1 squared. And if we simplify that down, looks like we've got negative 2x squared plus 2x plus 2 over x squared plus 1 squared, which isn't exactly one of our answer choices, but if we factor a negative and a 2 out of this, I'm not sure why I put that parenthesis there, but we'll end up with x squared minus x minus 1 over our original denominator there, which was x squared plus 1 squared. And now it looks like answer choice A. For number 16, we want to figure out if the derivative of this function at 1 is 2, 6, negative 2, negative 6, or non-existent. So the first thing to check is just to see if the function is continuous. Because if the function has a discontinuity at 1, then it can't have a derivative. So to find if it's continuous, we do the limit as x approaches 1 from the left, which is 2 times 1 minus 1, 1. And then we do the limit as x approaches 1 from the right of f of x, which is 3 times 1 squared plus 5, which would be 8. Well, the function is not continuous, right, because the limits don't equal each other. If the function is not continuous, then the derivative can't exist, and it should be choice E, non-existent. For number 17 here, we've got two functions, x squared plus 3x for y, and u is 4x plus 1. And we want dy du, which we don't actually have y in terms of u, so we can't directly take the derivative of y with respect to u. What we would have to do is, there's two options, and the probably worst option is to just solve this for x. If I solve that for x, I have x in terms of u, and then I can take whatever I get there and plug it in for the x's here. Then I would have y in terms of u, and I could just take the derivative. But since I know these things are related, I can remember the chain rule, right? dy dx is the same as dy du times du dx. And it should be really easy for me to find dy dx and du dx, because I have those functions, right? I have y in terms of x, so its derivative is 2x plus 3. I don't have dy du, that's what I'm looking for. But I do have du dx, right? If I have u equals 4x plus 1, du dx is just 4. So divide both sides by 4, and you get dy du is equal to 2x plus 3 over 4, which is answer choice D. All right, for number 18 here, we're again just going to take a derivative and then evaluate it at 8. So before I take this derivative, I'm going to rewrite it into just rational exponents here. So we're going to have 24x to the 1/3 minus 6x to the negative 1/3, because I think that just makes it easier to look at for a derivative. So the derivative should then be, with power rule, 8x to the negative 2/3, and then plus 2x to the negative 4/3. Well, that'll be 8 over x, which our x is 8. So 8 over 8 to the 2/3, and then plus 2 over 8 to the 4/3. Well, to find 8 to the 2/3, right? 8 to the 2/3 is just the cube root first. So if we cube root 8, we get 2, and then if we square it, we get 4. So we have 8 over 4 plus 2 over 8 to the 4/3. So we'll cube root the 8 to get 2, and then we'll raise it to the 4th power to get 16. So we get 2 plus 1/8. Well, 2 plus 1/8 would be 16/8 plus 1/8. That'd be 17/8. Answer choice D. For number 19 here, we're given a function f of x, x cubed minus 1. And then we say that g is a differentiable function. So we want to find the derivative of f of g of x. Well, f of g of x has to be found using, or its derivative has to be found using the chain rule. Right? The chain rule says that the derivative of f of g of x should become f prime of g of x times g prime of x. In other words, evaluate the derivative of f at g of x. So first we evaluate the derivative of f. F prime is 3x squared. So f prime of g of x should be 3 times g of x squared, right? We just replace the x with g of x. And then the derivative of g, well, we don't know what the derivative of g is because we don't have the function. So it's just 3g of x squared times g prime of x, which is answer choice D. All right, for number 20 here, we have sine x times tangent x, and we want to find the derivative at pi over 4. So we'll use the product rule to find that derivative. Y prime should be sine of x times the derivative of tangent, which is secant squared x, and then plus the derivative of sine of x, which is cosine of x, times tangent x. We can then just plug in pi over 4 in all of this. Right? The sine of pi over 4 times the secant squared of pi over 4 plus the cosine of pi over 4 times the tangent of pi over 4. Well, we probably know at least 3 of these right off the top of our head. Right? Sine of pi over 4 is root 2 over 2. We may not know secant or secant squared of pi over 4, but we should know cosine of pi over 4, root 2 over 2, and tangent pi over 4 is just 1. Well, if we're not sure about secant of pi over 4, right, remember that secant of pi over 4 is the same as 1 over the cosine of pi over 4, which is 1 over root 2 over 2. Or just 2 over root 2, which we could simplify, but we don't need to worry about it yet. If we want secant squared, then secant squared of pi over 4 should equal 2 over root 2 squared, which would be 4 over 2, or just 2. So it looks like we've got 2 root 2 over 2 plus 1 root 2 over 2, which should be 3 root 2 over 2. Choice A. So for number 21, we're looking at just the derivative of this function x plus 1 squared all being cubed. So what this is u cubed, right? Where u is equal to x plus 1 squared. So to take the derivative, we need to do 3u squared, or 3 times x plus 1 squared, right? That's 3u squared. Then we need to multiply that by the derivative of u. Well, the derivative of x is 1. And then the derivative of x plus 1 squared, well, that'd be like v is x plus 1, and we have v squared, right? So the derivative of that should just be 2 times v, 2 times x plus 1, times the derivative of v, which is just 1, so I don't really need to worry about that. Well, that doesn't really look like any of our answer choices. So we need to do a little bit of simplification here. It kind of looks like they've expanded out the stuff that's inside these squareds here for most of them. So let's, or at least for a couple of them. So let's see what happens if we do that. We have 3 times x plus, and then x plus 1 squared is x squared plus 2x plus 1 squared. And then this we can simplify, right? That's 2x plus 2 plus another 1, so 2x plus 3. And we then probably see that it looks like this is going to be answer choice E, right? 3 times 2x plus 3 is going to be 6x plus 9. And then inside those parentheses, I've got x squared plus 3x plus 1 squared, which looks just like choice E. For number 22, again, we're just looking for a derivative here. So our derivative is going to be found using the product rule, since it's 2x to the 5 halves times tangent x. So it should be 2x to the 5 halves times the derivative of tangent, which is secant squared, plus the derivative of 2x to the 5 halves. Well, 2 times 5 halves is 10 over 2, right, or 5. So 5x to the 3 halves, and then times tangent x. And so our answer choices doesn't look like our answer choices look exactly like any of those. So maybe we need to do a little bit of factoring out, since a couple of them have terms factored out. So we'll take out the x to the 3 halves, right, which is going to give us a 2x, right, because x to the 3 halves times 2x gives us 2x to the 5 halves. So 2x secant squared x, and then plus, well, we took out the x to the 3 halves, but we still have the 5, so plus 5 tangent x, which looks like answer choice A, just with these two terms switched around, which we can do. For number 23, this is again a product rule question, so we're just going to find the derivative using the product rule and then evaluate it at pi. So f prime of x is going to be x squared times the derivative of cosine squared, right? Well, that's u squared, where u is cosine. So it's 2u, so 2 of cosine x, and then times the derivative of cosine x, which is negative sine x. And then we'll add to that the derivative of x squared, which is 2x, times the cosine squared x. And we just want to evaluate this at pi. Well, conveniently, we know that the sine of pi is equal to 0. So if this term here is 0, all the stuff multiplied by it is going to be 0. So all we're really left with is 2 times x, or 2 times pi, times the cosine of pi squared, right? Cosine squared of pi. Well, the cosine of pi is -1, so we square that, we just get 1. Well, 2 pi times 1 is just answer choice B, 2 pi. For number 24, we're just looking for a third derivative. So we need a first derivative, which will be with the power rule. So f prime will equal 5 halves x to the 4th, and then minus 2x to the -3, and then the plus 3 goes away. Our second derivative, 4 times 5 halves is 20 halves, or 10, so 10x cubed. And then -2 times -3 should be positive 6x to the -4. And we drop down one more power here to get 30x squared minus 24x to the -5. So 30x squared minus 24x to the -5 looks like choice E. For number 25, we're going to take the derivative of 3 tangent squared 2x and then just evaluate it when x is pi over 8. So the derivative of 3 tangent squared 2x, well, that's 3u squared, where u is the tangent of 2x. So that'll be 6u, or 6 tangent 2x, times the derivative of tangent 2x. Well, we need to remember that the tangent of 2x is the tangent of v, where v is 2x. So we get times secant squared v, or secant squared 2x, and then times the derivative of 2x, which is 2. So we'll evaluate this at pi over 8. Well, 2 times pi over 8 is pi over 4, so both of those are going to become pi over 4s. So we have 6 tangent pi over 4, secant squared pi over 4, and then times 2. Now the tangent of pi over 4 is 1, and then the secant of pi over 4, right, we did that a couple of minutes ago, or we were looking actually for the secant squared of pi over 4. Right? And so just to remind ourselves, right, secant of pi over 4, or secant squared of pi over 4 is 1 over cosine squared of pi over 4, which is 1 over root 2 over 2 squared, which would be 1 over 2 over 4, which would be 4 over 2, which is, of course, 2. And then we'll multiply by this last 2. So we have 6 times 1 times 2 times 2, which ought to be choice E, 24. For number 26, we're just looking for a derivative here. So e to the x times cosine x will be done using the product rule. So it'll be e to the x times the derivative of cosine, which is a negative sine. And then we'll add to that the second function, the derivative of our first, which is e to the x, times our second, so cosine x times e to the x. And looks like we need to factor the e to the x out of this to get our final answer. We have e to the x times negative sine x plus cosine x. They've got it written with those flipped, cosine x minus sine x, but that's fine. That's option C. For number 27 here, we're looking at the limit as h approaches 0 of the cosecant of pi over 4 plus h minus the cosecant of pi over 4 all over h. Well, remember that this is just a form of the limit definition of the derivative, right? The limit definition of the derivative was this, right? The limit as h approaches 0, which we have, of a function, looks like our function is cosecant, of some x value, which looks like that's pi over 4 plus h minus the cosecant of that same x value all over h. So we know that this equals f prime of x. So this whole thing should be equal to the derivative of cosecant x evaluated at x equals pi over 4. Well, the derivative of cosecant, right, the derivative of the cosecant function is negative cosecant x cotangent x. So we're going to evaluate that at pi over 4. which means we need the negative cosecant of pi over 4 times the cotangent of pi over 4, right? And so if we're not necessarily doing a great job remembering all of our trig functions, just remember that the sine of pi over 4 is root 2 over 2, right? So the cosecant of pi over 4, right, is 2 over root 2. Well, we can leave it as 2 over root 2 if we want, but 2 over root 2 is like 2 to the first over 2 to the 1/2, right? Well, if they have the same base, we can subtract the exponent. So that's 2 to the 1/2, or root 2. So we've got negative root 2. And then the cotangent of pi over 4, we should know that that's just equal to 1. But if we weren't sure, right, remember cotangent is 1 over tangent, right? And the tangent of pi over 4 was 1, so we just get 1 over 1. We end up with an answer of negative root 2, which is choice B. For 28, this is essentially the exact same thing as the last one, except that instead of using h, they've used delta x, or a change in x value, which is what we know h to be. So this is just the derivative of the function sine x, but evaluated at pi over 3. Well, the derivative of sine x is just cosine x, so we want the derivative of cosine at pi over 3. Well, the cosine of pi over 3 is just 1/2, which is answer choice C. For number 29, we've got 5 cosine squared of pi minus x, and we want the derivative at pi over 2. So this is 5u squared, where u is the cosine of pi minus x. So this should become 10u, or 10 cosine of pi minus x, times the derivative of u. Well, u is the cosine of v, where v is pi minus x. So that should be the derivative of cosine is negative sine of pi minus x, and then times the derivative of pi minus x, which is just negative 1. We want to evaluate this at pi over 2. So we have 10 times the cosine of pi minus pi over 2, which would be the cosine of pi over 2, and then times the negative sine of pi minus pi over 2, which would be also pi over 2, times negative 1. Well, the cosine of pi over 2, this term right here, is equal to 0. So if that first term is equal to 0, and I'm multiplying it by a bunch of other stuff, all of which is defined, we just get 0, which is answer choice A. Okay, for number 30, we're looking for the slope of the tangent again at x equals 1. So we just want the derivative of this at x equals 1. So that'll be 3x squared minus 2y dy dx, using implicit differentiation, is equal to 0. Well, that tells us that dy dx is equal to negative 3x squared over negative 2y, if I bring this to the other side, or really just 3x squared over 2y, right? We can do it either way. And then we need to evaluate this when x is 1. Well, the problem is I don't have a y value. So in order to find the y value, I'm going to have to go back in and plug 1 into my original equation. Right, in my original equation, if x is 1, we have 1 cubed, which is 1, minus y squared is equal to 0. Is equal to 1. And so we can then just say, well, that's the same as negative y squared equals 0, or y is equal to 0. So we end up with 3 times 1 squared, which is 3, over 0, which is undefined. And so our derivative here, the slope of the tangent to the curve, is undefined. For number 31 here, we just want the derivative of this function at 0. And our derivative here we're going to find using the quotient rule, right? Because it's a quotient of two functions. So it should be the denominator times the derivative of the numerator, which will be 1 over 2 root x plus 1, times the derivative of x plus 1, which is just 1, so I don't need to worry about that. And then minus the numerator, root x plus 1, times the derivative of the denominator, which is 3x squared, all over that denominator squared. and we want to evaluate this at 0, well, if I evaluate this at 0, really all of these x terms are just going to go away. Right? In fact, this whole term is going to become 0, so that's just going to become 0. And that'll go away. So really, we're just left with a 2 over a 2 times the square root of 1, so 2 over 2, divided by 2 squared, which would be 1 over 4, which is answer choice D. For number 32 here, we've got f of x and g of x, and then we want to know what the derivative of h of x is at 2, where h of x is f times g. Well, I would just find h of x. H of x is x squared times 3x, right? H of x is just 3x cubed. So to find h prime of 2, find h prime of x, which is 9x squared, and then evaluate it at 2, which would be 9 times 2 squared, or 9 times 4, which is just 36. Choice D. For number 33, we want the derivative of 3 to the 4 minus x squared. So this is 3 to the u, where u is 4 minus x squared. So the derivative of 3 to the u is 3 to the u times the natural log of 3. And then, of course, times the derivative of u, which is just negative 2x. So it looks like in a slightly different order, right? They've got the negative 2x. They've got it in the exact reverse order, negative 2x times natural log of 3 times 3 to the 4 minus x squared. We've got choice B here. For number 34, we just want the derivative of this implicitly defined equation, so we'll use implicit differentiation to find that derivative. The derivative of x cubed is 3x squared. The derivative of 3xy will be 3x times the derivative of y with respect to x, plus the derivative of 3x, which is 3 times y, right? That's product rule. Right? And then plus 6y squared dy dx is equal to the derivative of 17, which is 0. Now we're just going to solve for dy dx. So I'm going to factor the dy dx out of the terms that have it on the left side, the 3x and the 6y squared. And then I'm going to subtract the negative 3x squared, or the 3x squared and the 3y to the right side, making it a negative 3x squared and a negative 3y. So we end up with dy dx is equal to negative 3x squared minus 3y over 3x plus 6y squared, which of course we can divide everything by 3, right? So we've got negative x squared minus y over x plus 2y squared. And so it doesn't quite look like any of our answer choices, but if we look at choice A and we think about distributing that minus sign through, right, we'll end up with the same thing that we have over here. In fact, we could just take the negative out of the numerator, leaving us with a positive x squared and a positive y, and an x plus 2y squared in the denominator, which shows us the answer is choice A. All right, for number 35, again, we're just looking for a derivative, right? It's 3 times tangent to the 5th of 2x. So that's 3u to the 5th, where u is the tangent of 2x, which we'll recognize that's a chain rule again. U is tangent v, where v is 2x. So the derivative of 3u to the 5th is 15u to the 4th, so tangent to the 4th of 2x. We're going to multiply by the derivative of u, so that'd be secant squared of v, or secant squared of 2x. And then we'll multiply by the derivative of v, which is just 2. And so looks like 15 times 2, of course, is 30. So we've got 30 tangent to the 4th 2x, secant squared 2x, which is choice E. For number 36 here, we've got f and g that are differentiable functions and are inverses of each other. Right? G of x equals f inverse. And we're given some values of f, f of 2 and f of 3, and the value of g prime at 4 and g prime at 9. and we want to know the value of f prime at 3. Well, this is an inverse rule problem. It tells us that f has a point 3 something. In fact, we know that point. It's 3, 9, which tells us that g must have the related point 9, 3. And the inverse rule says that the derivative of f at 3 should be 1 over, or the inverse of, the derivative of g at the related x value at that point, g prime of 9. So f prime of 3 is just 1 over g prime of 9. G prime of 9 was 1/6, so it's 1 over 1/6, which is just 6, which is answer choice D. And for number 37 here, we just want the derivative of this function at 4. Right? So, well, 1/32 times 4 would be 4/32, which is just 1/8. So 1/8 x cubed, and then minus 10x. And we want to evaluate this at 4. So g prime of 4 should just be 4 cubed, or 64 over 8, minus 10 times 4, so minus 40. So 64 over 8 is 8, so 8 minus 40 should be negative 32, which is answer choice B. And for number 38 here, we're just trying to find a derivative again. So we're looking for the derivative of x to the 5th minus x plus 2 over x cubed plus 7. So quotient of two functions. And so we just want to use the quotient rule. So it'll be the denominator, x cubed plus 7, times the derivative of the denominator, well, the derivative of x to the 5th is 5x to the 4th, and the derivative of minus x is minus 1, and the derivative of 2 is 0, so it goes away. So that's v du. And then minus the numerator, so x to the 5th minus x plus 2, times the derivative of the denominator, which will just be 3x squared, all over the denominator squared. And so it looks like that looks just like answer choice E. So got E for number 38. So for this next one, we're again looking at one that looks like a limit definition of the derivative. So we're just going to think about that rule. That rule says that if it's the limit as h approaches 0 of a function at x plus h minus that same function at x, then the x value we've got here is 1/2. And the function that we're looking at is f of x equals 5x to the 4th. And so all we need to do is evaluate the derivative of 5x to the 4th, which would be 20x cubed, at x equals 1/2. So that is 20 times 1/2 cubed, or 20/8, which we should be able to reduce down to 5/2. Should be answer choice A. For number 40 here, we're just looking at a product rule derivative again, right? Because we have u times v. So it'll be x squared times the derivative of the cosine of 2x. Well, to find the derivative of cosine of 2x, we'll call it cosine of v, where v is equal to 2x. We should just end up getting negative sine of v times 2, or negative 2 sine of 2x. Then we'll add to that the derivative of x squared, which is 2x, and then times the cosine of 2x. And so if we look over at our answer choices, it looks like that looks just like choice D. If we put the 2x cosine 2x in front, we end up with minus 2x squared sine 2x afterwards, which is choice D. For number 41, we're going to take the derivative of this implicitly. So the first part of it will be the x cubed y. We'll use the product rule, so that'll be x cubed times the derivative of y with respect to x, and then plus the derivative of x cubed, which is 3x squared, times y. Then we'll add to that the derivative of the xy cubed, so that'll be plus the x times the derivative of y cubed, which will be 3y squared dy dx, plus the derivative of x, which is 1, times y cubed. And on the right-hand side, the negative 10's derivative is just 0. So we'll get equals 0. Now we'll gather all of our dy dx terms on one side. I'll keep them on the left-hand side here. So we have dy dx is equal to, and that is equal to, but we have dy dx times x cubed plus 3xy squared when we factor out the dy dx. And on the other side, we have negative 3x squared y and a negative y cubed. And when we divide to get dy dx by itself, we'll have negative 3x squared y minus y cubed over x cubed plus 3x y squared. And so if we look at that, that's not exactly what any of our answer choices look like, but we should recognize that we can factor out a negative sign from the numerator. And if we do that, we'll have 3x squared y plus y cubed over x cubed plus 3xy squared with a negative sign out in front of everything. And that looks just like answer choice D. I've got these terms flipped around, but it doesn't really matter. For number 42, we've got a square root function, right? We have y is equal to the square root of u, where u is equal to 1 plus root x. So we'll use the chain rule here. So dy du should be equal to 1 over 2 root u, and du dx should just be equal to 1 over 2 root x. So if we multiply those two things together, we'll still have a 1 in the numerator. The 2's from each of them will multiply together to make 4. And we'll have root u, where u is 1 plus root x. And we'll have root x. So looks like that looks just like answer choice D, although I've got these two flipped around again. For number 43, we'll need to use the rule for inverse tangent or for arctangent. So this is arctangent of u, where u is equal to x squared plus 3x. So to take our derivative here, we're going to have 1 over 1 plus u squared times 2x plus 3, right? The derivative of each of those pieces. So that ends up being 2x plus 3, all divided by 1 plus x squared plus 3x squared. And if we expand out the x squared plus 3x, that'll be x to the 4th plus 6x cubed plus 9x squared. And then we still have the plus 1 there at the end. And so it looks like that looks like answer choice C. Just a few more to go here. For number 44, we've got sine squared x as our original function. We want to find the third derivative here. So first we'll need to find the first derivative. So we'll treat this like y equals u squared, where u is the sine of x. So our first derivative should be 2u times the derivative of sine, which is cosine, or 2 sine x cosine x. Now at this point, we know we need to take two more derivatives. And if we look at this, I think we can probably imagine that what's going to happen here is it's going to get a lot more complicated. We're going to use the product rule, and then we're going to have kind of a little bit of a mess going on for our third derivative. So it's really important that we recognize and utilize our double angle identities when we can. Right, so 2 sine x cosine x is the same thing as sine of 2x. That's a double angle identity that you need to have memorized. And we can see that 4 of our answer choices over here include a double angle. So it just makes sense for us to rewrite this as the double angle formula. So now we've got y prime or f prime of x is equal to the sine of 2x. To take the derivative of that, we're just going to treat this as if it is the sine of v where v is 2x. So our second derivative is going to be the cosine of 2x times 2, right? The cosine of v, where v is 2x, and then times the 2, right? And then we'll have to find our third derivative here. And now we'll be treating this as if it is, we'll do this off to the side here. This will be 2 cosine of w, where w is 2x. So the derivative of 2 cosine w is going to be negative 2 sine w. And again, w is 2x. And then we'll multiply by the derivative of the 2x, which is 2. So it looks like we get negative 4 times the sine of 2x, which is choice D. For number 45, we've got x plus the cosine of xy at 0, 1. We want to find the slope of the normal line. So first we'll need to find the slope of the tangent line. And remember that a normal line is perpendicular to our tangent line. Right? So perpendicular to our tangent line. So what we're going to do is we're going to take our derivative here. We'll do it implicitly. So the y becomes dy dx. The x becomes 1. And the cosine xy, well, that's cosine of u, where u is xy. So the derivative of that should be negative sine of u, which is xy, times the derivative of xy, done implicitly again. So that's going to be x times the derivative of y with respect to x, plus y times the derivative of x, which is 1. So we need to get all our dy dx's to one side. So in order to do that, first thing we're going to do is we're going to distribute this minus sine xy here to both of these terms. So we'll have dy dx is equal to 1 minus x sine xy dy dx minus y sine xy. And from there, we'll just add this x sine xy dy dx to the other side. And when we do that, we can factor out the dy dx. So we'll have dy dx is multiplied by the 1 from this dy dx, and then plus the x sine of xy. And then on the other side, we're just going to have the 1 minus y sine of xy. And when we divide, we get dy dx equals 1 minus y sine xy divided by 1 plus x sine of xy. And all we have to do is plug in our values of 0 and 1 for x and y. So in the numerator, we're going to have 1 minus 1 times the sine of 0. And in the denominator here, we're going to have 1 plus 0 times the sine of 0, which is just going to, I wrote a 0 there, is just going to come out to be 1 over 1, which should be 1, which looks like answer choice A, except that, oh yeah, we have to remember that what we're doing here is we're finding the slope of the normal line. And so that's perpendicular to the tangent line. So if our slope of our tangent line is 1, then the slope of our normal line should be the opposite reciprocal of that, which is negative 1. So for our second to last one here, we've got 3 to the pi x. We want its derivative. So that's going to be a derivative of 3 to the u, where u is pi x. So the derivative of 3 to the u is 3 to the u, or 3 to the pi x, times the natural log of 3. And then we're going to multiply that by the derivative of pi x, which is just pi. So it looks like that looks just like answer choice E, just in a slightly different order than I've got that multiplication written. All right, so for our last one here, we are looking at y equals u to the fourth, where u is equal to x cubed minus 2 over 2x to the fifth minus 1. So we start off with the 4u cubed, and then we multiply by the derivative of u using the quotient rule. So that should be the denominator, b, times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. And now we just need to evaluate this at x equals 1. So 4 is just 4. 1 cubed for our x cubed here is 1, minus the 2 gives us negative 1. And in the denominator, we have 1 to the fifth is 1, times 2 is 2, and then minus the 1 is 1. So we have 4 times negative 1 cubed. And then over here on the other side, the 2x to the fifth minus 1 is 1 again. 3x squared when x is 1 is equal to 3. X cubed minus 2 is equal to negative 1 when x is 1. And 10x to the fourth is equal to 10. And then it's all divided by 2x to the fifth minus 1. When x is 1, that's 1. And 1 squared, which will just be 1. So our simplification here looks like it's going to be a 4 times a negative 1. And then inside here we have a 3 minus a negative 10, which will be 13. And so 4 times negative 1 times 13 ought to be negative 52, which is answer choice A. And so that's the end of our walkthrough for the multiple choice derivatives homework assignment. And that's our last assignment of the derivatives unit.